Here we're going to look at topic 86, example 1, write equivalent rational expressions. So the question is, when are two rational expressions equivalent? So we're looking down here. If we do go back up to the concept though, we talk about rational expressions, which is going to be the quotient of two polynomials, and then the domain is all real numbers except those for which the denominator is equal to 0. We should know this, we've covered this in some previous sections. So the denominator, or x squared over x squared minus 9, is an example of a rational expression. And since the denominator cannot equal 0, you can set the denominator not equal to 0 and solve it. So you'd find that x cannot be 3 or negative 3. So the domain would be all real numbers except 3 and negative 3. When you're actually working with rational expressions and you're trying to find equivalent expressions, there's three things you want to look to do. The first is going to be factor, then state the domain, and then you are going to, we'll say, simplify, okay, or reduce. So step 1, factor. We want to factor both the numerator and the denominator as fully as we can. So if I look at the numerator, the first thing I notice is that each of these terms has an x value. So what I can do is I can factor that x out. That would be a GCF in this case. So I'd have x times, and I would be left with x squared minus 5x minus 24. And if I look at the denominator, I can actually do the same thing. I can take an x out. So I'm going to factor out an x, and I would be left with x squared plus x minus 72. Now there will be times that you are done at this step, but you should always look to see if the remaining piece, in this case this trinomial, can be factored still. So we want to look for factors of negative 24 that have a sum of negative 5. So we're going to use our factor sum chart. Actually, let's keep that highlighted. So I'm going to look for factors of negative 24 that have a sum of negative 5. So factors of negative 24, we have things like 2 and 12. We need a negative 5, so the larger one would be negative. So it comes out to negative 10, which doesn't work. I can use 3 and negative 8, which is in fact negative 5, so that checks out. So my factors would be 3 and negative 8. Be careful, make sure you bring that original x over. So let's keep that. We don't want to forget about that x term. And then I have the product of two binomials when I use the factor sum chart. So I'd have x plus 3 times x minus 8. So that would be the factored form. And I'm going to do the same thing with the denominator. All right, find factors of negative 72 that have a sum of 1. Factor this here. And factors of 72, you can try out numbers like, let's say 2 and 36. Now, obviously this is not going to work, but the better you are at factoring, the quicker you'll find these pairs. So I'm going to look at 8 and 9. The 8 would be negative. These add up to 1. You may have to go through some other factor pairs to eventually get there, but you will get the factors at some point. And let's not forget our x value, so I'm going to bring that x over. And then my binomial pairs would be x minus 8 times x plus 9. The order is not important. If you put the x plus 9 group first, that's fine. All right, so we have our fully factored numerator and fully factored denominator. So step 1, factor, is complete. Now we're going to state the domain. To find the domain, you want to look at each part of the denominator and set each part of the denominator equal to 0. So I'll write that over here. So x will be equal to 0. Right, so that's the green x. The x minus 8 will be equal to 0, and x minus 9 would be equal to 0. So if I solve each of these, let's just put some dotted lines here. If I solve each of these, this would be x equals 8, and this would be x equals 9. Remember, since it's in the denominator, this is what x is not allowed to equal. Let's show where we got these from. So when I'm stating my domain, which I will state, we'll just state over here. So my domain is going to be all real numbers except x equals 0, positive 8, positive 8. I messed up here. Let's go back. This should be x plus 9. So right here, that should be x plus 9. So my x value would be x equals 9. Apologize for that. So x equals 0, 8, and negative 9 for my domain. There are other ways to phrase the domain. You can use interval notation. You could say x does not equal 0, x does not equal 8, x does not equal negative 9. But for our purposes, we're going to state all real numbers and then list the exceptions. So it's kind of like what they show up here. Right? All real numbers except whatever ones that we cannot have. Right? So that's our domain. Usually the domain is pretty straightforward. You're just looking at the denominator and you're finding the exceptions. So these would be our exceptions. All right, and then our final step, we just need to simplify or reduce. So if I look at this expression, I'm looking for groups that match up, right, or that pair up. So in my numerator and in my denominator, I have an x value, so I can cancel these x's out. I can also cancel out the x minus 8 and the x minus 8 from the denominator as well as the numerator. The groups need to be exactly the same, so make sure they pair up. All we are left with in the numerator is x plus 3. I like to keep it in parentheses to remind myself that that's a group. And in the denominator, we have x plus 9. That would be our final equivalent expression or simplified expression. And we would just box that in. Now, what you want to be careful of, common mistake, is if we don't put this in parentheses and we look at this way, sometimes it's assumed or people think that you can cancel these x's out. You cannot do that. All right, the x and the 3 are tied together with that addition, so you can only eliminate groups, or if there's things through multiplication, like we had the x values just before, but you cannot cancel out x's if it's something like x plus 3 and x plus 9. So I always like to put those in parentheses to remind myself that they're a group, they stay together, and if I want to cancel out, in this case, the x, I have to cancel out the entire expression, x plus 3. All right, that is it for this type of problem. They're not too bad. Most of the work and the difficulty with these is going to be in factoring. The domain, you take each part, you set it equals 0, you find your exceptions, and simplifying, you're just looking for matching groups or matching pairs, matching terms in the numerator denominator that you can cancel out. Okay, but the factoring, you need to be familiar with your factoring methods.